Hello everybody, welcome back. Last time we were here, I was talking about the definition of electricity. Definition of electricity, as we said, is the movement of electrons. Okay, the electrons in motion makes those electrons we call electricity. We can see it in lightning, right? Cloud goes by, it's got all the electrons stirred all up, and they're looking for a place to go into the earth. And so once they start moving, traveling, that becomes electricity or lightning, and it goes through a tree. And the resistance of that tree is so much that the tree gets so hot it catches on fire, and the electrons are flowing through that tree. So let me show you what the flow of electrons and the control of the flow of electrons, what we do as electricians. We got to keep it under control, right? So we have a source of electricity. The source of electricity could be a battery, could be a water generator, water wheel turning in the water, windmill, whatever. Something gets those electrons ready to move, and all they need is a path to follow, right? So the electrons that are in this battery are stirred up looking for a way to flow on this path. This path might be the wire that goes through a switch. When this switch goes up and makes contact here, those electrons have a path to flow through to this light bulb. They go through this little tiny resistance in this light bulb that actually is catching on fire inside the glass bulb and getting hot and creating visible light, and the electrons are flowing back to the source. And at the source, the chemicals in this battery stirring up those electrons, providing the force, providing the energy to get those electrons to move. Remember yesterday I was talking about the drop of water. You get some kind of pressure of a little bit of a drop of water on one end of a hose, and it's going to come out the other end of the hose. Well, the pressure here would be this chemical reaction that gets this electron moving. If those electrons are wanting to move along that wire, you can see that if we had the switch off, we have the switch open, we have the switch not connecting here, the electrons aren't going to flow through this open space. Right? In order for those electrons to flow, we're going to have to move this switch up, make a connection here, make this thing go up, and make a connection here. So we have to create a path for the electrons to flow on. Right? Remember, this is like the water hose full of water. This is copper wire full of atoms of copper. So the electrons on that copper wire are just sitting there looking for someone to bump one electron, which bumps the next one, bumps the next one, bumps the next one, and it bumps all these electrons, goes through this light bulb, creates this visible light, and the electrons flow back around and come back to the source, and around they go. All of this happening at the speed of light, 186,000 miles per second. Right? You could change this to a nuclear power plant, creating a bunch of steam, getting these electrons to start flow. What we're interested in today is focusing on the fact that we can control the flow. Once we open this switch, electrons still want to go, but they got no place to go. They bump into this copper, and there's no place more for the next electron to bump into the next electron because we have an open connection here, right? We call this an open. Make sense so far? We're going to continue on this subject of controlling the flow of electrons. And we're going to answer the question of, where does the light go when the light goes out? Don't be silly. It doesn't go anywhere, does it? So, electrons won't flow if the circuit's open. Next subject is going to be taking a look at all these variety of source that we have. We have a source of electron flow, and there's a number of them. We'll cover some of those next time. Okay, bye.